this computer, and I'm recording now. Any other questions or things to remind me not to forget? All right, then I'm going to shift over to doing a problem, I guess. So I'll stop sharing that. And here's what I got planned here. All right, we got all 8 now, and it just automatically repopulated. I'm going to do a problem. I think I can close this now. Yep, I don't need that. And don't save. I'm going to share with you the worksheet for today. Come on, we can do this. Where's there? There we go. Share it. There's the worksheet. 3 problems are on the worksheet today if you open it up. And I'm going to do the third one, frankly, because it's the easiest. And then I've got Zoom set up to divide into 2 groups. And it just did it randomly. The first group is Amaya, Justin, Prince, and Sam. Hey, look at that. And then Ania, Max, Seed, and Shneha, you're in the other group. And I'm hoping, if I'm saying your names wrong, guys, send me an email. Just say, hey, get my name right, because I apologize, especially early in the morning. I'm not quite awake yet, I guess. I'm going to do the third problem here, okay? Like I said, it's the easiest. And I'll give you some hints on how to get this first and the second one set up. They're not that hard. You're going to use those equations that I showed, so you may have to look at them up. We're going to do them on the whiteboard, okay? And while we're right here, let's read the third problem so we got it. And I'm going to transfer over to the AWW app whiteboard. So I've got a radioactive nucleus. It's moving at half the speed of light. Okay, so the speed of the K prime frame is a half the speed of light. This nucleus decays and it emits an electron with a speed of 0.9 of the speed of light. And if you've never studied chemistry or radioactive decay, it is often the case that when an atom or an object decays, it emits something. It's a very common thing. In this case, it's an electron which is being emitted. U-235 obviously emits neutrons, and that's what sustains fission reaction. Anyway, so it emits this thing. What I want to find is the velocity of that electron that we're being told is 0.9 c in the frame of reference of the nucleus, right? We want to find what the velocity of that electron would be in the laboratory frame. A similar problem to what I did last night. So I'm going to stop sharing that and instead share the whiteboard, and then we'll just keep that right there, share that, and I guess I can put the poll away because that's just bugging me, and we'll leave chat up. I posted that whiteboard so that you can all see it. I posted it in the chat so you can get yourself in. I see 2 people are in. So it may be that you changed your names though. All right, but here's what I guess we got to do. I got to draw a picture because anytime you're, let me resize this. Yeah, there we go. Let's resize it. Okay. Anytime you do a physics problem, we'll draw the picture. There's this for me, my stationary frame K, and that's my X axis. And then the nucleus guy, we'll put him up here. There's my nucleus, and it's moving. So it's meant to be at the origin of the prime frame, K prime. And of course, out of this guy, it decays and it shoots, there's a little electron, and it shoots it out with a velocity. And we said that velocity was U sub x equals 0.9 c. Okay, and of course, the frame has a velocity that we said was a half, 6/10, 0.5. You start doing so many of these, you just forget. So that's my picture. Everybody good? And what we want to know is what's U sub x seen over here. And notice as is typical, we got the x and the x prime frames parallel to each other. And so I guess, having wrote that down, the only thing I got to do is get my equation. And I don't have these memorized either, quite frankly, but I did recall that x prime plus the speed of the frame. This is a case where you're going from the prime to the unprime. You always add the velocity in that case. I forget it a lot of times too. I have to go look it up on equation sheets. Special relativity, not my research area. And I chose to write it like this. That's a c squared right there. And then in the x case, this is x this is x, and by the way, that's prime, and that is in the numerator, and that gives me the unprimed. Okay. So let's see. That's u sub x prime. That's the 0.9c plus, let's see, the 0.5c. And you can see right there, that would be 1.5c. That would violate the speed of light. I sometimes like to write this a little different. Couldn't you have written this as 1 plus beta ux prime over c? You know, when textbooks, ours being no exception, tend to write it like that. But what is beta for this problem? Beta is 0.5, right? And further, what is ux prime over c? Ux prime over c, that's 0.9. So if you write it like this, the denominator is a little easier. Let's see, 1.4c, that's the impossible answer. That's why we have to be decreasing it somehow. And the answer is we're dividing it by 1 plus beta, which is 0.5. And then that's a decimal point right there, 0.9 right here. Okay, and you know, obviously this is greater than 1, so that saves the day mathematically. We can't be greater than the speed of light. When I do this, 1 plus 0.5 and 0.9, that's 0.35, I guess, isn't it? Or is that no, I'm sorry, 4.5. What am I thinking? 9 times 5 is 45. So this is 1.4c divided by 1.45c. Less than 1. That's a good thing. And so I put that in my calculator. I got 0.966c. Okay, so that's the first problem. And any questions on that? Then I'm going to do something I've never done before. I'm going to open all the rooms. Okay, I'm going to stop sharing so that, and you should find yourself in rooms. Can I share who with particular people? And on the whiteboard, and let me designate some space here. One of the things I can do is, let's minimize my problem. And I think I can select it maybe. Nope, all that does is cross it out. Yeah, let's put it right there in the middle. Okay, so the breakout group 1, that's Amaya, Justin, Prince, and Sam. Sam, you haven't joined. How do I get you in there? In any event, I want you to do problem 1 on the worksheet, okay, right over here. And the other group, which is Anaya, Max, Said, and Shneha, you guys are going to work problem 2 over here. So this is group 2, and this is group 1. All right. And apparently, I'm able to jump in between groups. So I'm going to try to do that. So the first thing I would recommend somebody to do, I'm going to make Amaya, you're the leader for group 1, and Anaya, you're the leader for group 2. So let's get a picture drawn. And let me clear some clutter off my screen. I can clear that away. I can minimize that. All right, I think. Sam, you're in. Okay, good.
Yeah, take it back to 3.
All right, I'm okay if you want to do it there. If you don't want, if you guys don't want to use my AWW app, you got something better. Just you guys, but you guys are doing problem 1. You can do it wherever you want. Okay.
Okay.
Very cool.
Yeah. I didn't mean to. I didn't. If you have a better tool, I'm. Let me know what it is, and I may try to use it too.
Awesome.
Okay. So I don't see a picture for you guys though. That's the problem I just did. All right. Yeah, so get a picture up there. I'm gonna leave you guys and go check on the other group.
Great, thank you.
Yay. Hi.
All right, I joined your group. You seem you guys are using your own way too, rather than you're gonna use, if you can write right on this, I'm good with it.
Yeah, we can write it. But we were just we didn't know which question to do, honestly.
You're group 2, so you're doing problem 2 here.
Oh, sorry, Naya.
Okay.
And I was aiming for 1. Okay.
Yeah,
All right.
that's the other group. Yeah, so draw a picture real quick, and then I'll get out of your way.
Awesome. So okay, wait, it says repeat problem 1. Okay, but
If
okay.
A travels with a velocity in the y direction, point A.
This is
So draw like that.
I'm just
Yeah,
gonna,
there you go.
but are we in the should I call this the y and y prime frame or something?
Use K because they're gonna use K later in question B.
Use the handwriting. This is physics stuff. Okay, so it travels in the y direction, right? So I'm just gonna make it look like it's going up there. Now this is technically supposed to be ux, right? Wait, u prime x, right? No, wait, what I'm saying, uy.
How do we decide which frame is stationary when both the motions are in 2 different directions?
Yeah.
They'll tell us in B, but yeah. So if the Earth is stationary, frame K, then rocket B will be the moving one.
Oh.
Yep.
So rocket B is to the left, 0.60 C.
This is
And-
cool. This is a nice question.
Yep. You Mr. Jabber, I think you nailed it right there. So the stationary frame K, that's the Earth, right? And you're measuring the rocket A is 0.8 C in the y direction. That's relative to Earth, right? Yeah, so in the K frame, you've got a rocket moving in the y direction at 0.8 C. And the K frame is the Earth's frame.
Okay, so both of them, so if we're going relative to Earth, then that would mean one of them is going, then both of them are in the K prime frame then, right?
No, I don't think that's what it's saying. Rocket 1 is traveling with a velocity of 0.8 C in the y direction, and that is relative to the Earth. So that velocity is in the K frame.
Okay.
To make the vertical guy, the 0.8 C be in the K frame.
Wait, how did we decide that?
Yeah, that's my question.
Read question 1. You guys were in question 1. You look at question 1. Rocket A travels to the right with a speed of 0.8 C, and rocket B travels to the left, both relative to Earth. And so what we've done now is we've turned rocket A to the y direction, relative to the Earth.
Yeah, but the only thing I can't seem to decide is that which frame they are in, because if both of them are traveling, you know, in either direction, in question 1 they're both traveling to the left, why would one of them be in the K frame? I thought both of them would be in the K prime frame if they're both relative to Earth.
The Earth is the stationary frame.
Yeah, that's what I think.
Okay. So you have labeled the velocity in the K frame. What do you know? It's good there to leave it. What are you going to call that? The component of velocity in the y direction, uy?
Well, if we establish like this is the one that the rocket A is actually traveling in the K frame, yeah, it's obviously like
that's uy, right?
C.
Okay, and label it uy. Okay, good.
I. What do you mean by
For the
I?
Y. Y for
Y,
vertical.
okay.
Y, vertical. Perfect. Okay. Now, rocket B is supposed to be the moving frame, and it's going in the other direction. So I
Yeah.
guess, now you're fine there. You're just going to make it negative, right?
So yeah, so I'm just gonna do this.
Yeah, there you go. And that's got a velocity V. And what's its velocity?
Oh, well, it's obviously 0.6 c.
And it's negative, right?
Yeah, so it's negative 0.6 c. Okay. Oh,
Yeah.
but wait, this is our v. Just like we call this just v.
That's
That's
just V.
Okay.
Okay. So now I think we've answered, we've got a picture now. And I think what are V? We got V. We know what that is. Well, let's see, beta and gamma from that 0.6. I guess you got to do that. We got UX. What is UX?
Wait, ux
Yeah.
is
There is none, right?
there is none. Yeah.
It's only going in the Y direction.
Yeah, so it's 0.
Zero.
So
The
Yeah.
equation for uy is uy over gamma 1 plus b over c u prime x. So then that would just be 0.
Yeah. And
So then
the,
it simplifies to like a
the only thing
simpler-
I'm gonna ask you, that you put a plus sign in there. You're going from the stationary to the moving, right? So is it a plus sign or a minus sign? Check those equations. But you're on the
u prime the negative going negative will only change the negative the sign of the
Yeah,
u
exactly.
prime x equation.
Exactly. All right, so now it's time to just plug and chug here. Find beta, find gamma, find ux prime, and find uy prime. Right, so go ahead and do that calculation, and I'll leave you guys alone to do that.
Awesome, thanks.
You bet.
Awesome.
Leave you guys.
Okay, guys, so I'm just gonna write these down so we're kind of clear.
You
This
know
is
what?
technically 0. I thought I would just wait till the end whenever. But what did you get? Like, I would write it down if you have it.
I think I got
1.25.
yes. And then we just have to
1.25, right?
multiply it by 1 because there.
Would space these out more, so I had space to draw
Yeah.
something.
He like expects us to sketch a whole entire fucking thing.
Sorry
How
about
small I
that.
gotta do this.
I probably could on this one since it was only a one-page thing. I could have gone to a second page.
Yeah, like how problem 3's set up. I really like that. How I
You
would
had
just,
good distance on problem 3. I do
well,
play with that.
this just creates a page, I think, and that's why I had space. But still,
Sure. Okay.
even like this right here, I mean, that's pretty big.
Yeah. All right. So what do you guys decided here? You got
I
any-
don't know, kind of confused.
Okay. So let's label the things. I think the most important thing is labeling. You've got B. What are we trying to find? So we want to find the speed of rocket A in the B frame, and you've got rocket B moving to the left at 0.6 c. I like it. Why is that the speed of the frame?
Where?
The 0.6 c. Remember, we distinguished.
Oh yeah, okay.
So that's, and now what you're calling VA. I don't like that labeling because
Be
that's, yeah, you want U, don't you?
rocket.
Yeah. And now you can apply the equations.
I guess I could call this like U X A.
Sure. Yeah. Okay. And truthfully, you don't even need the A anymore, but that is just, no, that's V, right? That's the speed of the moving frame of object B. So I was okay with V for that one.
So why is you say this one is V?
That's V. And that coordinate system on the left, moving or stationary?
Stationary.
Well, if I got V going to the left, make the coordinate system on the left K prime.
This one.
Yeah. okay, and make the coordinate system on the right K. And now just make sure we match the given information. We're saying that the rocket A is being given relative to the Earth with a speed of 0.8 c, right?
Yeah.
Okay, so that would be u sub x, no prime, just u sub x is 0.8 c. The k prime frame is moving to the left at 0.6 c, so I think that is the velocity of the moving frame. Rocket B is your moving frame, and so now we want to convert u sub x over to u sub x prime, where the rocket B is the prime frame. That makes sense?
Kind of, but
Yeah, there you go. That's the
well, it's
equation.
just it's a lot to take in.
Yeah. And the key is what part C is asking for. It's asking for what's the speed of rocket A, which is being given by u sub x in the stationary frame, relative to rocket B, which we've just decided was the K prime frame.
Okay. Okay. Yeah, I think I can work with that now.
Okay?
We had this equation.
Adequate, but you're going the other way though, right?
Yeah, so the signs are gonna have to
You make
flip.
that a negative sign for velocity and a negative sign in the velocity in the denominator as well. Yep, yep. And then shift the
I gotta
primes and
change
then,
my
yeah, there you go. Get rid of that. That's just u sub x. Okay, and it's primed is what it's equal to. Yeah, there you go. Solve
all
it.
right.
Something like this.
Solve it. And yeah, you do have a negative negative here, don't you?
Is it something like this?
Is that 1.4 over 1 plus?
1.4.
This would
Like
be
1.4 over 2.4.
Not quite. I finished the math here. I agree with the 0.8 c. Yeah, there you go. Look at that. It even straightens out your line for you.
1 minus
0.58 c. Is that
over. I'm just gonna write c squared. Like
Yep. Well, the c's will
Time.
cancel for you then. 0.8.
yeah, 0.8.
c?
And then the two c's cancel the c squared, right?
Get
This.
0.58 c.
So,
Yeah, that.
so
0.58 c.
All right, may I trust you?
I wouldn't. Hang on here.
I want to work it out. My
No,
calculator.
I wouldn't trust him. I think you got the minus because what's in the
Oh,
numerator?
wait. My bad.
Yeah, numerator is 1.4. That's clear. I don't trust the 0.58.
Eight
It's not correct.
divided by
It's,
9.
All right, you guys got it though. You're almost there. I'm gonna go check the other group out.
Oh, what did I get?
In the Y prime frame. Okay, he's here. That's great.
All right, I think I'm back. All right, so
Oh, because relative to rocket.
0.6. Okay, for your u sub x, or that's a u, right? U sub x, 0.6 c. I agree with
Yeah.
that. No
Okay.
doubt about that. It's true.
So they had Max just had a question, which is interesting. So this is obviously in the Y. It's in the prime frame. But we were like, if the rocket is going up and, it has a first in the K frame, it has a 0, its speed in the X direction is 0. But why does it have a velocity in the prime?
Yeah, so why is the y direction dependent on the x velocity?
Yeah, that's the.
Yeah, that's an interesting question. That is the distortion of space due to special relativity, isn't it?
Oh, you talked about this in one of the
And all
reviews.
we're basically saying that space is warped. There's a couple pictures in your book where they draw like not a cube, but if it's a rectangular cube, whatever you call parallel pipette, I don't even know what that's called. And you can see as the thing moves, it distorts in space. Okay.
Wow.
But the answer is, I think you're right. Now, I was looking, my answer is, what is 1.92 divided by 3? I'm looking for it as a fraction of the speed of light, because you may be right there. Divided by 3. Yeah, you're right. I just expressed it as a factor times the speed of light, but 1.92 times 10 to the 8th meters per second is the right answer. So you guys are good. We're going to end here. We're going to get back together and compare answers. So
Great.
closing in 1 minute, or closing in a minute here, or in a second or two.
Awesome.
Good job, guys.
Yeah, you got it. Yeah.
All right, good guys. Do this more.
I'm able to tell you that. So hopefully you're getting a message saying we're closing up all rooms.
Perfect. Okay.
Okay, I got 3 of you here. Look at that. Technology in action. Didn't lose anybody, I hope. I lost one of my rooms. Hate when that happened. Where'd they go? Oh, closing in 27 seconds. That's why. They'll be back.
So that's the interesting thing about this. So from the outside, from a person relative to the Earth, like standing on Earth, the rocket would technically be moving just up. But when you're on the, like, when you're in the space, like in rocket B, for example,
Yeah.
you would, I don't know if you would feel like you're going in in an X direction, but I know that, you know, constant velocity makes you feel like you're stationary, but
Yeah.
that's an interesting thing.
Yeah. And yeah, you look back and the rocket isn't going vertical. It's moving with both an X and a Y component, right? If you're in rocket B, we'll talk about that.
Yeah.
All right. So I'm going to give, let's see, security. I can let you guys share anybody. Okay. And so question 1, make sure who is question 1? That's Sam. That's you, right? That was your thing. Can
Yeah,
you
I
share your
guess.
screen with everybody?
Well, Amaya's telling me I'm wrong, and I don't know where.
Well, post it up. Well, you were really close.
Okay,
Just
let
the
me
math.
Post it up and we'll make a
let me fill
decision.
this out again.
Just the math.
Okay, here I go.
All right. Where's your board? Share it.
I'm trying.
Okay.
Takes a second.
Yeah. Trust me, I know.
All right,
All right. There it is.
I got to here.
All right. So tell the other group what your problem is too, just so they can come up to speed.
And I don't even really know what my problem
All
is.
right.
I got confused.
Okay. Well, right in the middle here is Earth, right?
Yeah.
Okay. This thing going off to the right, that is rocket A, right?
Going off to the right. This, yeah, A would be over here.
And this is B going off to the left.
B.
And what we wanted to know was what's the speed of A in B's frame. Good to go so far? That's what we're ultimately asking in C. What is the speed of the rocket A here in the moving frame of rocket B? And so key to getting this problem right, I think, was the identification of the parts.
I think that's the most difficult part of it.
Yeah, absolutely. Setting it up is, I mean, the math, we're going to argue about that in a second, but I don't know that your equation there is right. It's just a matter of getting the numbers right in your calculator. But does everybody see that the way we've drawn this answers question C, compute the speed ux prime, which is the speed of rocket A, which is u sub x, but you want to convert it over to the K prime frame, which is the frame of B. Okay? And so I agree with these 2 assignments. And we decided that this is K prime is moving that way, okay? And so all you had to do is get the correct equation, and both groups are moving from a velocity specified in a stationary frame, converting it over to one specified relative to a moving frame, in both cases rocket B. All right, so here's the X equation, and just plug in u sub X, plug in the speed of the moving frame, 0.6 c, and you have this minus a minus case. And so that numerator is 1.4. And then you have 1 minus, it just turns out to be 0.6 times 0.8. What's 0.6 times 0.8?
48.
Or
0.48, and you've got minus a minus, right? So it's 1 plus 0.48. So I don't know what you guys were arguing apparently, right? This is 1.4 divided by 1.48 times C. And we got 1.4 divided by 1.48.
Ah,
0.95.
Yeah,
I need to get
0.95 basically.
Yep.
Okay.
so I was right.
Yeah.
No, it's my
I
calculator.
think, was it the minus the minus?
No,
No,
I was right.
my
but they
calculator.
told me I was wrong.
You're all
No,
right.
no, my calculator bugged out.
Oh yeah.
Maya said it was wrong. Get it written.
Dude,
Well,
I need
but
to get a new calculator.
but think about how physics works and how you've, I hope, have always been graded. It's pan out just a little bit. You've got the right labeling on your diagram, which I think we've said, and I agree with, is sometimes the hardest part, right? Taking these word problems and making a picture where you've labeled all the appropriate parts correctly, okay? And then you have to make sure you've got the correct equation, okay, which is in this case going from a stationary frame where you know rocket A's speed to the moving frame of rocket B where you want to get rocket A's speed. And then once you've got the right equation, then you insert carefully all the pieces that you know, and you get the right answer. That thing you put a box around is worth the least of all of what it was involved in solving this problem. You know, I'm teaching the 101 students, trying to get them to draw a picture. And you know, you guys would say, oh, their word problems are easy, okay? But they still struggle with exactly what you all were struggling with, was to draw this picture in part A from these set of words in problem 1, part A, B, and C, okay? But you got it, you got it. All right, so now we're gonna go on to the other one. Stop sharing if you would, Sam. And who was doing problem 2?
Oh, I was doing it.
Okay, if you pop it up.
Yep, working on it.
Yeah, I know, it takes a second.
Yeah.
Very similar problem. They just turned rocket A from heading along the X direction
Ooh.
to going on the vertical direction, okay? And
Little
they
bit.
chose to put the K prime frame over on the right side, but they still have it moving at minus 0.6 C, right? Only see they've swung the U, the velocity in the Earth's frame, from going to the X direction to going to the Y direction. Right, see how the picture's different? And they had to calculate beta and gamma because their Y component equation has a gamma in it. And I think they did that right. They got gamma for the prime frame was 1.25. I agree with that. And then when they did the X, and those V's look a little bit like U's to me, so we'll pretend they're U's, okay?
Yeah.
UX prime, exactly the same thing, only if you look in the denominator, they have no X component of velocity because rocket A is only moving in the Y direction. And so you can see where they crossed out that term in the bottom, and it just became 0.6 C, which I guess is exactly what it was. Well, it's exactly the frame's motion, right? But the Y equation, it actually does change speed. And so, but again, they can say the UX is 0, so they were able to cancel that, but they had to divide the 0.8 C divided by gamma, and they get 0.64 C. And this is kind of unique now, because what this tells you is, even though in the stationary frame, the rocket only has a Y component, when they transferred it over to the moving frame, rocket B going off to the left there looks behind, and it sees the rocket A both moving vertically and moving away from it horizontally, right? And that was kind of the surprise of this problem, is that the rocket, which only had a Y component to velocity in the Earth's frame, in the stationary frame, picked up both an X and a Y component of velocity in the moving frame. Space is sort
That's
of being,
crazy.
yeah, space is being distorted a little bit. Okay, you look back in your rear view mirror, and sure, you see it going up, but you also see that you're leaving it. It's going back behind you. Okay, and you think you're stationary, so you tell yourself, oh, it's not just going vertical, it's going vertical and it's being left in my wake. Both. Kind of bizarre, but true. All right, any questions? Hey, you're both using an app that's much better than mine. Would you send me emails, the two people, and that's what's Sam, you got it, and Saeed, right? I think, Saeed, you told me about this last year. If you send me
I did. I'm just gonna type it in the chat right now.
okay, that'd be great. Type it into chat before you guys leave. Then have a good weekend. Remember, your WebAssign homework is due on Monday, and you don't have a worksheet to do now, because everybody having been participating in this exercise, you'll all just get 4 for the worksheet for today in the grade book. All right.
Perfect.
All right.
Ready, break.
All right. Thank you. Have a good
You
weekend.
bet. Have a good weekend, guys and gals.
you. Yeah, so I just typed it in the chat. It's called Notability.
Okay, Notability. I got to check that one out. Yeah, you mentioned that last year a couple times to me, and I'm sure I got it written down somewhere, but thank you.
Yeah, it can be helpful. Yeah, all right.
Yes.
All right, have a great weekend.
You too.
Thank you.
Hey, Professor, I have a quick. I was trying to log into WebAssign, and I'm kind of having challenges paying for it.
Okay.
It keeps on. So, like, for the quiz for today, I'm gonna hand it in a bit late.
Can you see the problems at all?
Sia just sent me a link like 5 minutes before class, but that wasn't enough to do it. So I tried to log in with the app, and I'm not being able to see my account.
Let me go over there and check it. Hang on one second. Let's see if it shows you being in. Let me minimize that. Bring that over here. WebAssign. What is my password?
I'm also having problems paying for it, because I've been trying to, because I think my expiration thing is going
Yeah,
to.
if you're on a 2-week trial, that's coming due here. It's probably, you should be, well, it depends what time you logged in, but it should have been 2 weeks from the 23rd of August, which would end on Sunday of this week right here, I think. All right, let me look at my grade book here. Two, three, four, five. Okay, it still shows you're here, you're in. Log info.
I know I've made an account, but when I try access it, it's only Sayed's link, which took me directly to it. When I try and just search it up, I've been having challenges.
Okay. So you're not even able to open the website.
Yeah.
Okay, so let me, yeah, because it recognizes you. You're in my grade book. Let's go back here. So I'm going to put something into chat here. Go to that website. Tell me what you see.
Cengage web sign.
Okay. And let me log in one more second here. Hang on before you go on. Try to log in right there. And I'll check what parameters it thinks you should be using. Roster.
And still loading.
Okay, your login should be your email at Washington College.
That's the one I used.
Okay.
It just shows the textbook for my course. It shows the modern physics for scientists and
Okay.
the free study tools.
So let me try to log in as if I'm you. Log in. Not there. And it thinks come on. Copy. Okay, that's Safari. So it thinks that. And are you sure you're putting in the right password here?
Didn't we have to make a password?
Yeah, I should. When you log into WebAssign, here, try this WebAssign. Yeah, because when I go if you hit that link and put your email in, you need to give it a password too. And if you've forgotten it, there's a button that it says forgot, and then it should send you either a new password or what your password is. That's the one thing.
Yeah, I have the password, like, because I saved it, so I just like click on sign in.
Okay.
And then after signing in, I just see the textbooks for the course, which is what is it?
Modern physics with
modern physics and study notes, free study tools, and that's
okay.
it.
You don't see my assignments?
No.
Click on that textbook, see what happens.
It just says purchase access or enter access code.
Yeah, okay. So can I see that screen? Share it with me if you would for just a second. Okay, did you already buy the access code from the bookstore?
No. I try to do it here with the homework only access,
right.
But it doesn't quite go through.
Okay, yep, go ahead.
This is.
And that is probably the cheapest way, I'll bet. And then you don't need both of them. Let's see. Hang on a second. Yeah, you want the bottom one because it's single term. Yeah, so remove that one. Yeah.
So is my free like access run out?
Yeah, I think that's what's going on here. Yeah,
because I try to do
short. Yeah, I think it shorted you a couple days, didn't it? Yeah, you got to pay it $40 to move on.
Oh, okay. So could I get like an extension for the quiz?
Oh yeah, the quiz that was due today. Yeah, I'll put it to Monday for you.
Awesome, thank you.
All right. You have a good weekend.
Awesome. See ya.
All right. Bye-bye.